Okay, ET means the environmental dust trap, the outdoor environmental dust trap. So answer 1 can pull from the 4 to 20 milliamp output. We can use Ethernet to pull the data up. We can use number 3, environment communication system. Number 4 is Track Pro. That's the software. Okay, we have more than one answer. Okay, you don't have all. The AM520. 1, parasitic, extraparasitic and inhalable dust. 2, total dust. PM1, PM10. Answer 3, PM4, PM5, PM10 and 0.8 micrometer. Answer 4, ultrafines and nanoparticles. So what size fractions can be measured with AM520? Yes. Okay. Question 8. If I want to measure number of particles in the air corresponding to 2.5 micrometer, can I use dust trap to measure? Yes, this one you just put yes or no. Okay? So number 8 is either yes or no. Okay, what is the intrinsically safe rating of N520i? Number 1, it is IB-BB-T3GB. Number 2, IA-CC-T5GA or IC-AA-T3GB. And the last one, answer 4 is IA-CC-T4GA. So which one? So we just put either one of the answer. Okay. The new high capacity battery will provide a runtime of 1, 8 hours, 2, 10 hours, 3, 15 hours, or 4, 20 hours. This new high capacity battery I mean is the AM520. I'm referring to the AM520 or new product. Okay. Question 11. The intrinsic safety rating for AM520i will permit operation in atmospheres containing which of the following? Answer 1, methane and underground coal mining. Number 2, methane, propane, petrol and most industrial hydrocarbons. 3, ethylene, coke, argon gas. 4, hydrogen, acetate, carbon disulfide. Or 5, 4 the above. So which is the correct answer? Which of the following is not true? It's not true for dust, environmental dust trap. Okay, this is the environmental dust trap, which is not true. Real-time dust monitor. Answer 2, instant access data. 3, certified equivalent system. 4, for any outdoor environment. So which is not the true answer? It's not the correct answer. Okay, next. Okay, which of the following is not a targeted customer of the environmental dust trap? 1, industrial fan lines. 2, air quality consultants or engineering office. 4, sorry. So 1, that one just put 1, 2, 4, 5, whichever is the answer. Okay, there's no 3 here, there's no answer 3, okay? So 4 is the personal aerosol monitoring. 5 is the outdoor construction site. So take note, this question has no answers 3. Okay, so it's just 1, 2, 4, or 5. Either one will get. Okay, it's not which of the following is not a targeted customer of the environmental dust trap. Okay, I think this is the last question. Okay, can the AM520i be used in atmospheres containing gases with auto emission temperature of 300 degrees Celsius? Can this equipment be used? Yes. Then answer 1, no. Answer 2, 3 depends. Okay? That's it. Oops. Okay, I can collect back the paper and we will know the results after that.
Don't pass all the papers.
This is the last question, okay? Can the AF520I be used in atmospheres containing gases with optimal emission temperature of 20 degrees Celsius? This is also be used. Yes. Answer 1, no. Answer 2.
That's all right. Okay.
Selanjutnya akan ada hands-on training dari Miss produk. Langsung saja saya serahkan kepada Dr. Heng.
Hi, good afternoon everyone. I hope you have your nice lunch. So for the next 45 minutes or less, I will be demonstrating a hands-on session with SKC products with the support from Mr. Hani from PTHAS. But before we do that, probably I will do just to describe a little bit on what we will be doing at, for the next 45 minutes or so. So what I will be showing is actually an active air sampling approach. So what does active air sampling approach mean? Which means we need certain components. So the definitions are here. Active air sampling defined as the collection of compounds or contaminant using a mechanical device. In this case, we're using a sampling pump to draw the air and contaminant mixture through a sampling device. But because what we are doing today is more related to dust exposure sampling, I will be demonstrating the use of putting on the active air sampling accessories with a PM sampling kit. So that is what we will be doing. So maybe just to let you know what are the components which you will be seeing later, just to define so that if you have any questions, they will be related to one of these three over here. So we will be using sampling pump, which I have a new model which I will show you later on the robustness and the hardiness of this particular model of sampling pump. And we have a calibrator. So what is a calibrator? A calibrator is a unit, is an instrument to quantify how much air volume is going through a filter or a sorbent. That is what we are doing. And then last but not least, we are using a sampling media. So this particular sampling media will be using a filter, so you will see how total dust is being performed later. So that is basically what we are going to show. And okay, this is just one of the last slides that I would like to show you. So when you are performing, so let's say you are in a field performing sampling or so, there are basically two modes. Either we use an integrated or we use a grab sampling. Grab sampling means I want to know what is the situation at a particular point of time. So this is what I mean by grab sampling, short time. Integrated sampling means it is over an average time. So for instance, we're looking at 8 hours, 6 hours, 7 hours, depending on your work time. So in the case of this active air sampling approach right now, what we'll be showing, it's basically what I'm trying to show is for long-term type of the sampling approach. And yeah. So flow rate options, you will be seeing these as well. Although the demonstration will be on particulates, but we will also be showing you, or Mr. Hani from PTHAS will be showing you what, how is this gas and vapor sampling flow rate like, because these are in very, very different type of flow rate. Gas and vapor, typically the flow rate are much lower. We are looking at milliliters per minute. But for particulates, that means for dust, we are looking at liters per minute. That is the difference between these two. Now, before we start, I would like to show you a particular video. This is what we will be using for our demo, which I thought that it is quite interesting to show that hopefully you can hear something. If not, I think the graphic will be fine as well. It's just a 2 minutes video. This is the particular sampling pump that we will be using. So this is the air-check touch. We actually drop it from the facility from 2 level down to the ground level on the concrete floor. Okay, so my colleague is the one, you can see the shadow holding the camera to ensure that the pumps are still working fine. Okay, so this is what you'll be seeing later or what we'll be using later, but not dropping the pump. So 4 liters per minute, the very same pump, so everything is still fine. Okay, I would like to show you a particular video. So this is another test that we actually show the robustness of the pump by splashing with water. Very unconventional way. In fact, I have a few requests just now whether I could do the real demo on site over here. I have certain challenges, so which is why I can only show a video, unfortunately. So splash test, the pump is still in working condition. So anyway, this is just to show you that the pumps that we manufacture actually has to go through tests like this to ensure that out in the field under very severe conditions they are able to function as intended. So this is a very safe pump that has been dropped from the 2nd level to the ground floor. Okay, so still okay. So this was not enough. My colleague took the pump after the splash test, went to the 2nd floor again and dropped the very pump, the very same pump again. So if you hear, yeah, no special effect, all real. So by the way, this facility, this is the SKC facility at Pittsburgh. So it should be working, if I remember correctly. Yeah. Okay, 4 liters per minute. So we will be using this. So like what I mentioned earlier on, this is not called the air-check pump. This is the air-check touch. But because of this video, we actually rename it as an air-check pump. The demonstration will be using this very same pump. So feel free to actually adjust the flow rate. You can actually see the flow rate. But before we start, maybe let me get the pump over here, and then I will just call a volunteer. So to actually show how this PM sampling head are attached to your collar or to your breathing zone, and then with the pump. So after that, I will suggest to split this all the participants into 2 groups. So the first group actually will have a hands-on, you can actually play the pump itself. While the second group, I will show you what are the other accessories for gas and vapor sampling or for bed sampling, because the group is very big. So unfortunately, I have to split this all the participants into 2 groups later. Okay, so what I have on the demo set over here, this is the pump that we'll be using, the air-check touch, and this will be used for total dust sampling. While this particular one, a very robust looking one, this is called our universal pump. So we'll be using this to connect with solvent tubes. So just a second, let's wait for my colleague. So Hanif will support this demonstration, but before that, maybe I could call for a volunteer. Before we get the volunteer, I would maybe state my specifications for the volunteer. Preferably, you have not performed dust sampling with personal sampling pump before, but you are working in the line. So that means you may be doing dust sampling in the next couple of months or next few weeks or even tomorrow or so. So it's actually a very good training ground for you that I would advise you how to actually wear this particular sampling pump and also the sampling cartridges and such. So are there any volunteers that would like to be my model? Anyone? Okay, so applause for this gentleman over here. And you are?
Mulyani.
Thank you, sir. So we will start off with this particular one. So this is the palm that we mentioned. So remember earlier on I mentioned that in the case of active sampling palm, we need a pump. And then we need the solvent media or filter media. So in that case, that will be the filter. It's this particular filter. That is what we are using. And the third component is a flow calibrator. In this particular case, what we'll be using is, I'll use a rotometer, but there are also other calibrators that actually can be used over here. Okay, so maybe I will explain, and then Honey, maybe you can, Mr. Honey can help me support this. So what we will do is, remember just imagine this particular one. First of all, we need to calibrate the flow rate of this filter, or the flow entering the piece of filter itself. So we calibrate to, let's say, 1 liter per minute. Okay, so if you want to show. So we will just demo 1-to-1 over here, but later you have actually a better view on this. So what Hanif is doing right now is he is connecting the sampling pump from one end to connecting to this particular filter cassette over here. This filter cassette, there are 2 connectors, and at the other end is going to a flow meter, which I'm using a rotometer just for simplicity, just for the demonstration purpose over here. So what Hanif is doing right now, as he's doing, he's placing the piece, the filter cartridge into the filter holder. So I will let the gentleman walk down so that you can actually take a picture of him with the full setup. So this is how it looks like right now. After we place the filter cassette in the filter holder, this is how it looks like. Okay? So what we need to do before we can actually start to wear is to determine the flow going into the filter cassette right now. So we try to adjust it so that the flow rate is 1 liter per minute under this condition right now. Okay, so difficult to see, but I'll just explain. So currently, the sampling pump is connected to the filter is connected to the flow meter. Okay. Okay, so based on the flow rate that is shown on the rotometer, don't worry, we will come down later. Based on the flow rate that is shown on the rotometer right now, Mr. Hanif will adjust the flow rate to what we require, so that will be the flow rate that we will be using on site. Okay? Okay, so now we managed to get 1. So you see, this is the case of calibration. After we calibrate, this sampling train is now calibrated and it can be worn by the wearer. So once this is done, so we will now put the sampling accessories on this gentleman over here. So what we will typically do, there are 2 things that you have to take note of. The pump and also the sample, actually probably 3 things. The position of the pump. Where is this line from the pump to the filter itself, and where do you hang the filter cassette? So typically in the case of a sampling pump, we try to hang it on the belt. If you have a harness, we will attach it to the harness. Now there is this breathing line right now, you see over here. So this one, as much as possible, fine, yeah? Okay. Okay. So as much as possible, this line has to be unobstructed. So you can actually wear it in front, or you put it behind you. So what we see over here, it's like that. This is the condition. So, but this is just one of them. There are different methods of doing that. And you ensure that, look at the breathing zone over here. The filter actually is in the breathing zone of your face. So how do we define my breathing zone? Your nose and your mouth. If you can draw a big bubble, 1 feet bubble, so that is actually the breathing zone. So this is one way of actually wearing the pump itself. But let's say if you are worried about this particular, there's actually another different method of doing it. I'll just show you. So one variation is like that. Remember, the line is in front of you. So I'll show you the second method. what I have done is I actually pull the line and I go behind him. So you can actually see it is still here, but maybe I can trouble you to. So the line is behind here. So maybe when I explaining, may I trouble maybe walk one down. So just remember now that although he's just walking very freely, but you see there's no obstruction. His hand movement, he can move his hips around. It doesn't actually remove or disconnect the line. So actually this is what sampling is all about, or when you're wearing the accessory, the full accessories. In this particular case, this is for dust sampling. But let's say if he were to put on solvent tube sampling, it's the same as well. So remember, when you're wearing it, as little restriction as possible. So now that he has worn this, he has to actually start the pump. So if you want to start the pump, you just have to put this open, hit the icon. There you go. So now the pump has started to work, and what he's supposed to do actually is to take down the time that he starts, and then let's say for instance if you work for 6 hours, 8 hours, wearing this pump, after the time, then he will switch off the pump again. So he has the time start and time end that will give us the sampling time, sampling duration, and multiplied by the flow rate, which is 1 liters per minute, that will give us the volume of air that is drawn through the filter. So this is actually what laboratory will analyze the flow rate. So just for instance, take for an example, 8 hours already. So what you do is, okay, then switch off the pump. That's all. So as simple as it is. So remember that initially we had the calibration, correct? So calibration was with Mr. Hanif. So now after the process has been completed, we should always check at the end of the sampling whether it is still at 1 liters per minute. So we get Mr. Hanif to help me do a post check again. So remember, before we do the measurements, we do a pre-cal. And after the measurements or after the sampling, we do a second time. So very carefully, Hanif will remove the sampling pump and the filter, and he will connect to the flow meter again to ensure that the flow is correct. So there are always a lot of questions. For instance, I mean, some of the more frequent question is, why do we have to do a before and after, even if everything is done correctly? Now the issue is because we are using filter papers or even solvent paint, over time, when we collect enough dust or enough compounds, the back pressure will increase. We have to ensure that the pump is able to support this. So now Hanif is checking the post measurement to see whether the pump or the flow rate going through the filter is still as intended. So yeah, he's looking at it and it seems okay. Yeah? Yeah.
Okay if the measurement is not precisely 1 liter per minute?
There is an allowance. It depends on the allowance. Typically we look at 5%. It really, if 5% is your tolerance, then we look at 5%. But do know that currently we are using a rotometer. So rotometer, unfortunately, because the accuracy of a rotometer typically is half scale and above. This is the most accurate. So anything half scale and below, the accuracy of the rotometer is not as good. So most of the time, actually, we will use a digital flow meter. But for the case of the demo today, because I wanted everybody to be able to see that flow rate, which is why I chose a rotometer instead. But it doesn't mean that the rotometer is not accurate. So it's okay, it depends on what is your tolerance right now. So in this particular case, pre-flow rate, post-flow rate, about the same, pass. Okay, so this is what actually the wearing of this sampling pump is all about. So what I'm going to do next is, let me check how much time do I have. More than enough time, yeah? So I will split this group or all the participants into 2 groups. So the first group will follow me. The second group will follow Mr. Hanif. So Mr. Hanif will show the operation of the calibration, what those probably at the back you did not see early on just now. So Mr. Hanif will show you how to actually adjust the flow rate accordingly. While for the group that is attached to me, I will show you other than dust sampling, what are the other accessories that are available, so that you can actually also have an idea that it's not just dust sampling alone. There's still gas and vapor sampling, and then if you do not have a sampling pump, there are other methods such as passive samplers, but I will try to show you on the demo hands-on session. So maybe what I can do is, let's have a fair split system right now. This group over here, follow me. Okay? And then this table, 1, 2, 3, these 3 tables, you join this group over here, follow me. So the last 3 rows and that section, go to Mr. Hanif, and then after about 10 minutes, the 2 groups will just switch over. Okay, so then everybody will have enough time for interaction. So Hanif, would you like to, maybe you use the table over here, and then you show them on the dust calibration, it's easier. Okay, so Hanif will be there while I have a magic case over here. So my group, come to me, I will show you what is in this particular case, and then if you have some questions, we will take this time to discuss as well. My group too many, doesn't matter, maybe we squeeze a little bit. I will try to talk louder without the microphone. So we can take picture, it's okay, but feel free to actually walk around. I'll just pass sample around also. So SKC, we manufacture sampling pumps, and we also manufacture sampling kits like this. What I showed you earlier on, just now that 45 minutes, was just total dust, inhalable dust, respirable dust. Very, very small items, but I have more things over here to actually show you. So remember the PPI, those that do not have a chance to see the PPI, it's okay, I'll explain 2-3 times so we can have a chance. So remember we talked about the PPI just now, parallel particle detector. So these are the parallel particle detector. I'll pass round again. You note the sampling rate. This is 8 liters per minute. Very, very high sampling rate. So if your environment is very clean, you want to do respirable dust, you need to use something like that. And I have other colors as well. Okay, so maybe I'll pass round again. You can take a look. Same thing, different color. This is 4 liters per minute for respirable dust. Okay, I will cover the dust and then I'll go to the gas and vapor so we will see everything. Okay, this looks the same. This is for thoracic. Remember thoracic, similar to PM10. Okay, so this just pass around, it's okay. Make sure that you return to me after that. Okay, because my demo gets smaller and smaller every time after my demonstration. Maybe pass to the back. Yeah, that is for thoracic. Looks the same, but the design is slightly different. This one is for lower flow, 2 liters per minute. Okay, so this type is with plastic. I do have another one. This is made from aluminium. The plastic one is one-time use only. After we use, we throw away. This one is reusable. Okay, so this is reusable. So we will also use the principle is the same. I have 4 inlets, and I'm able to sample them. Okay, so now come the interesting part. Let's say you are not only doing workplace exposure monitoring, you are also doing ambient air monitoring. Because ambient air monitoring, we do not we are not looking at respirable, we are not looking at thoracic. We look at PM 2.5, we look at PM10, correct? So that is the
Frans Fernandes, salam kenal misi.
Oke, siap.
This is a PM 2.5 sampling gate.
Gua, lu ada kabel USB lebih panjang nggak?
Dia nggak punya sampling gate.
Tak buka itunya. Ininya. Turun dong.
So you realize that actually there are protection theory, but by changing certain physical design, I'm able to sample particles of different sizes. So PM 2.5 here, feel free to open up so you can actually see some seat and a place that you can actually put pieces of filter paper. And this one is a higher flow. This is up to 10 liters per minute. This is for PM10 also. So I understand that sometimes environmental and workplace, there is a mix right now. So that is the reason why we developed this or sampling heads as well. So this one is for 10 liters per minute, PM10. So remember earlier on I mentioned about asbestos cassette. Asbestos cassette are like that. Okay, so inside I have a MCE filter. Okay, so how we do it is we open up. Here will go directly to my sample pump, and the air will go in through here. There is a mixed cellulose ester filter inside. After sampling, I will digest the filter, and then I can count how many asbestos fibers are there inside. So this passes around the picture is the same concept. I need to draw air through the MCE filter. So asbestos cassette. Okay. What other toys do I have over here? I'll show you. This one I think I've seen earlier on. This is just normal filter, PVC filter. I have another one over here. This one is for microbiome sampling. So if you are also in the works of doing microbiome sampling also, we use this type of cassette. So we are able to track the living spores, and then we look through a microscope to see what are they. It's called Versal trap. It's actually a sticky plate. Just to see what are the microbiome spores that are there. Okay? So which one? This one? It's just like that. Okay. And then, remember the diesel particulate sampler DPM that I mentioned to you earlier on. This is how it looks like. So if you do it like that, actually this is dust sampling. Now we go into gas and vapor sampling. Gas and vapor sampling, the concept is similar. I have a pump. But now my media is very different. My media looks like that. It can be in the form of this type, cleanup tube, or it can be in the form of solvent tube, like that. I have different sizes. So this is for active sampling. So remember active sampling, I need to pull through, I need to have a sampling pump. And I also have weird things like that. This is an OVS tube. This one is for pesticides. So if you are doing, for instance, farmer, you want to check for pesticides. This application is this one. Explosive, this type. So you see, that little guy with a Mexican cap. So we manufacture all this for inside application. We do have different solvent material. So again, I'll pass this around. You can actually take a look. Okay. So all these are with active sampling. Now the question is, I talk so much about active. We have a mode for passive sampling. Passive sampling means no harm. Answer, yes. SKC do have, we manufacture these as well. So this is what we have. These are called passive samplers. Some of these are in standards already. For formaldehyde, for ambient air, if you are doing the nitrogen oxides, we have. For ammonia gases, we have. These are passive samplers. Passive samplers means I do not have a sampling pump right now. So I go on site, I wear it. Okay? So when I start to work, I expose this. After 8 hours, I push it back. That's all. Send this to the laboratory for analyze. And then they will let us know what is the mass of the collected sample, and then we divide by the duration of time, and that is how we get the concentration. So if you are doing benzene also, or even let's say organic mercury vapor, we do have this. This is called a VOC check. If you are familiar with the 3M passive sampler, this works better. It has double the solvent rate. So principle is the same. So again, I wear this on my collar first. When I reach the work site, I will open up the cap like that, exposed already. Okay? 8 hours later, or 6 hours after your working time, I cap it back.
Yes.
Done. So I do not have a team. It's just like that, and pass it to the laboratory. Laboratory ALS, for instance, I mean, they are able to do it. Or if you are running a laboratory, you can actually do it yourself because we do have all the procedures for you. So this is passive sampler site, and you have a pump that you draw the vacuum. So you force the bag to inflate itself. So it is an indirect approach. I have some drawings that I can actually show you if you have time later. So there are two ways of bag filling. So if the let me see if you have questions of bag filling, don't worry, you can write to me. I can actually show you. Or let me see if I have some time. I pull out the slides and I can show you the two different methods of bag filling. But I would always recommend the negative way, not the positive way, because positive way you run into the risk of contamination. Okay? You can use. If your pump is very clean, it's not an issue. Sometimes the issue is your air is dirty. You pull through your pump, you contaminate your pump, it goes through your first bag. Then you go on a different side, same contaminated pump, and you run through again. So that is an issue. I have an enclosure. We have an enclosure. You can actually see that. I'll show you the slides later. Any questions? Just a second, yeah? Stay here first, relax. We relax, they are very busy over there. Too many questions. The good thing I got the easier group. This is for cyclone. Yeah, cyclone is for respirable dust.
How many use the bag?
The bag, okay. Typically, bags should only be used once. Yes, because if you see, the what we are always afraid of is contaminant. Especially if let's say you are sampling the gases is for regulatory purpose. You can find somebody, you need to stop work. People will question you the accuracy of the work. So if your bag is contaminated, and then you do it for sampling again, it's not too good. But having said that, I know there are people, there are users that actually flush the bag. It's doable, but from manufacturing standpoint, I would not agree to that. But if you treat it carefully, I would say it's possible, but always move with care. That's what I mentioned. Yeah. So again, it's just like the positive bag filling method. I'm not saying that it's wrong. I'm just saying that when you do it, be careful. Know your conditions. Because if you know your conditions, you can collect your sample more accurately. Okay, good. If this is 10 liters per minute, 10 liters per minute, you need to use the SAC like this pump. The bigger pump. No, the regular pump can only run up to 5 liters, it's not strong enough. You need a higher flow rate. Yeah. So some of the kits over here, you see they are for indoor air quality as well. And some they are using it for environmental, but with some modifications. Yes.
Belum ada gitu. Dengan kaset yang rendah tuh Pak.
Not the entire cassette, but you send the filter. You have to take the filter carefully and then you pass it to the laboratory. Or if you have a if you already have a microbalance, you can actually do it yourself. Yeah, but not the entire thing. We need to get the filter out. The filter is inside actually. Plastic, petri dish. I will always recommend petri dish or filter holder if we have. So that is the regular one. No, the regular one is not strong enough. You need a higher flow rate. So some of the kits over here, you see they are for indoor air quality as well. And some get it. After that, after sampling, take up some filter, put on the filter holder, and then pass it to the laboratory. That's how you do it. All filters, strictly one-time use only. Yeah, you have for things disposable, you cannot reuse filters. Yeah, because the holder is reusable. So yeah, so you just put in another. I mean, you first of all you have to weigh the filter first, and then before you can put it. For mercury vapor. Yeah, mercury vapor, sometimes when they are drilling, there are some organic. This one is for benzene, for VOCs. For VOCs, for mercury you can choose the filter.
Kalau misalnya pelatihan tangan di antel
2,5 juta diskusi itu filter kalau satu set mahal itu kan sama alat ya. Satu alat ini satu paket itu ada paket sih. Kalau dia mau ganti filter kan 100 lebih dalam urusan itu. Nah, ada anak universitas undip Ponorogo, jadi dia buat tugas itu. Bukan lab, dia ada tugas, dosennya minjemin dia alat itu sampel gitu kan, tapi filternya harus beli. Nah, dinyari susah. Kamu udah 5 list.
Okay, so now
Terus apa? Nanti kamu bisa baca itu. Baru 2 hari sih. 2 hari yang sekarang.
just one of the room. Yeah, just for demo. When you buy them all, I'm very happy. Okay, let me put back my things first. Then I can show you better, yeah? Okay, so let me stand here, easier. So, now, what we have over here, earlier on, maybe you want to, earlier on I showed you dust sampling, but that's not all. SKC manufactured everything from here. So remember I mentioned about respirable dust, I mentioned about thoracic fractions. Now I have more. Okay? I did not have time to show you, but now I have time to show you everything. The red one, when you take a look at this is 8 liters per minute. Okay? I have 2 liters per minute. I have 2 liters per minute. This one is 4 liters per minute. Okay? And I also have for the thoracic fraction. So remember the thoracic fraction is similar to PM10 around there, yeah? Not exactly same, but similar. Okay, let's take a look at this one. This is for industrial hygiene. But let's say if you are also doing ambient air quality. Ambient air quality, we talk about PM2.5 and PM10, correct? Then yes, we do have. This is PM2.5 sampler, PM10 sampler. Okay, it's written over here. So again, take a look. Remember to return me after that, yeah? Okay? Now, the thing about PM10, PM2.5 sometimes is we would like to have a higher flow rate. What I pass over, these are 2 liters per minute. This one over here, this is 10 liters per minute. Very, very high flow rate for accuracy. Because remember, the rule of the time, the more dust you can collect, the more accurate it is. So this one is a PEM, we call it personal environmental monitor. So you can actually, again, where there's a collar over here, you can measure how much you are exposed to PM10. Filter better. Okay, pass it out. You take a look. Okay. So what else do I have? So remember earlier on I mentioned about asbestos. I talked about dust, I talked about asbestos. This one over here is an asbestos, like I said. So there is an AC filter inside. you open up, okay, so the air will actually goes through. This is MCE filter, white color. Okay, so this is MCE filter. After collecting, we will then digest this filter and we will count the number of fibers. So it is with a different enclosure right now. So this is a clean filter, no asbestos fibers, so don't worry. All safe, all my things are safe. Okay, take a look. So those are for asbestos, but we SKC do not stop there. If you are interested in doing microbiological sampling also, we also do have. This is for quite a versatile track. You can actually find spores, microbial contaminants, sticky plate. Once it's there, then we can actually look under the microscope. We can look at the structure, the morphological structure. So this is for microbiological. Asbestos count. Asbestos standard is number of fibers per cc. Yeah. So the weight doesn't matter because if you have a fiber, the fiber is dangerous. The concentration doesn't matter anymore. So that's why we call it a count concentration. Now, remember earlier on I mentioned about the diesel particulate measurement? This, if I were to do it like that, this is for DPM, diesel particulate matter sampling technique. So with that, I'm able to sample diesel right now. Traditional method mentioned in the NIOSH as well. Again, fast enough. For diesel, we're looking at like 0.8 microns and below. That is what we are looking at.
Could we sample the side from horse and like this?
Not enough, because if you do like that, it's total dust. If you want to do DPM specify that the size is very, very small. So which is why you need to remove the big fraction, you only look at the small fraction. So this is the only way to do it. Because you see, cyclone will remove the big particle. The smaller one will go up. But if you use like that directly, total dust. I'm not using this one yet. Yeah, if you do like that, you are taking total dust. You are taking total dust plus DPM. So your food is the same because you need to remove the size. You will use this, you are not removing the size. You use this so that you can remove the size. So you need to have pre-selection first. That means a pre-filter. This is the way of doing it. So be careful. You can do this. You still can analyze based on the DPM method because definitely there is soot particle. But your answer is combined. You are not really splitting up the soot particles because the soot particles has a definition of size right now. But this is total. So maybe if you are looking at really doing the soot, you really have to look into this one, DPM method. This method is described in the NIOSH method right now. Okay. So over at honey section, we look at solvent tube already, correct? So I will show you other solvent tube. For instance, sometimes we use T-nuts like that. So T-nuts can also be used also. So these are active sampling. But if you do not do active, we also can have passive. Passive means we sample without sampling count. Take a look. So what we do is we go on site, hang it over here. So open up, expose. 8 hours later, push it back, send this to the laboratory for analysis. That's all. Passive sampling. So what I have, these 3 colors over here for maldehyde, NO, and then for ammonia gas. Let's say if you want to do VOCs, are you familiar with the 3M passive samplers? This is even better. Double the size, more than twice of the solvent bed. We put it on like that. Go on site, remove it like that. So after 8 hours, close it back, done. Send to the laboratory. It doesn't come in the metal casing. Just like that, the laboratory can analyze. VOCs. This is for VOC. Yeah. So for volatile organic compounds. So if you are concerned with mercury vapor, this one. This is for mercury vapor. Passive samplers also. After we sample, we send to the laboratory for analysis. Mercury vapor. Oil and gas industry use a lot of this. Okay, so for mercury vapor, can take a look. Yep. So last but not least, there will be situations that you go on site. You know that you need to measure something, but you do not know what to collect. So this is the time that we deploy sampling bags. Kevlar, flex foil plus. Again, you can see there are different material. Sometimes, I give an example. Maybe the gas that you are collecting is sensitive to light also. This is ideal. Other than that, you can actually use this other method. So what I show you here is not all what SKC is doing. We are doing a lot more, but because of the time, I can only show you what I have over here. If you have any other question, write to me. You have my email address, you have PT House address. I will be very happy to support your questions or anything that you have any questions about. Okay? Any questions on this so far?
Can we?
This is the treated filter I showed you. Depending on what you want to test, the papers are different. You see, there are two pieces of filter over here. Not paper, filter paper. One is a control, and one is the exposed one. So, formaldehyde, pH method, so it really depends on what compounds are we getting. So, very good question. This is no. What is the maximum? Maximum capacity. This is work for workplace type of the scenario. So whatever that we can expect in a normal workplace, it's not an issue. Yeah, this is not an issue. So it's we are not putting it under extreme condition. If it's extreme condition, then we have to be careful. But shouldn't be an issue. So for instance, VOC checks, what you saw over there, that one has twice the solvent bed as the 3M sampler. So I'm not afraid of the capacity right now.
What about the humidity level for this passage?
Good question. Humidity may affect or can affect passive sampler, but it also affects active samplers. Nobody asked that question before, because when you're doing active, you're also drawing the wet air through the tube. This is the same thing. So whatever is affecting the solvent tube is affecting this as well. But when we are running through specific validation for this, we actually took into consideration of the humidity as well. It's not an issue. So these, the VOC checks, these are validated already. But there is influence over there. Good question. Any more? The same question as the other group. From manufacturer standpoint, I need to keep the sample as clean as possible. So I would always recommend one-time use only. But if you want to use for multiple use, I'm not saying cannot, but you need to purge the bag very, very carefully. Because some of the gases, when they stick, or even wet gas, semi-volatile, when they stick, very difficult to push them out. So if you want to do that, can, but be very, very careful. So, but if you ask me as a manufacturer, I recommend, I didn't say must, I said I recommend one-time use.
One more question.
Yes, please.
How to protect this sample from the tampering from the people, maybe exposing something that
Very difficult. Very difficult. So that is the reason why, in order to do that, maybe we need to go into the statistical analysis already. Are you doing only one sample, or are you doing 3 samples? Or I always go in terms of odd numbers: 1, 3, 5, 7, 9. So that if, let's say, 3 samples, 1 has been tampered, but 2 is good. I know this 2 is okay. Yeah, 5 samples, likewise, I will see what is that. So it's you have to base on statistical analysis to remove the outlier or one out. That is the only way.
not all of them tampered.
Then you're either very lucky or unlucky in the situation. Okay? So let me check with the other group, and then if they're okay, we will go on to the bottom now. Then from PSI. So remaining questions, we will keep it and then ask me per email or from PT House itself. Let me just ask the other side. Done? Okay, thank you for your attention.
Sini ya, Pak.
They will let you know. This is correct. Thank you very much. Thank you.
Ya baik, terima kasih kepada Dr. Candy Levin dan Bapak Hanif Perdana selaku Product Manager dari salah satu produk SKC dan DSI. Selanjutnya hands-on training untuk produk berikutnya dari DSI. Dari alat gas rem nanti, jadi alat tersebut merupakan monitoring real-time gas, PM10, total gas, PM2,5 dan PM1 secara real-time gitu ya. Jadi bisa kita melihat secara langsung bagaimana kinerja alat tersebut. Ini alatnya sudah ada.
Potongin apa? Sini.
Nggak bisa, salah sih.
Oke, maaf untuk alat yang didemokan saat ini adalah alat protokol, bukan alat dasar ya. Alat protokol untuk respirator fit test. Jadi efektivitas masker yang digunakan oleh pekerja.
Sofia sama.
Baik, langsung saja saya serahkan ke Ibu Sofia.
Okay, first let me talk about this REST fit testing first, what is all about, before we go and do the demo on this. Okay? It will take some time to warm up. Can you turn this equipment on here? Okay, so what is REST fit? So what is respirator fit testing? What does it mean actually? Okay, in OSHA 29, CFR 1910.134. 134 talks about respiratory protection program. Okay, in this program, they have this whole medical evaluation of the employee who has to wear a respirator. They have to do some medical evaluation. Is he fit to wear a respirator? Because respirator is quite toxic, right? So is he fit to even wear a respirator? What about does he know how to maintain his respirator? When he wear the respirator, does he know how to store them and keep them, right? So all this is very important. And where does TSI comes in? TSI comes in this respirator fit testing, which is this equipment that you see here, okay? So, and OSHA mandates REST fit testing as part of this respiratory protection program. It's a program, okay? So they perform all this, and the last part is the REST fit testing, okay? So what is actually a respirator fit testing? You see the highlighted zone here. Okay, it's like around the face seal. So when you go on the respirator, you want to make sure that the respirator fits you. Okay, that you are wearing the correct model, the correct size of the respirator. Okay, an M respirator suits you might not suit me, right? So every respirator has its own different size. Okay, so we have to make sure that the respirator suits you, because we know that by wearing a respirator, we are protecting from the contaminant in the environment. That's why we need to wear a respirator. So even if you don't wear it correctly, you are not ensure of a safety work environment, right? So you have to make sure you are wearing correctly. So when we do fit tests, why should we even do fit tests? Talk about safety. So there's a satisfactory seal of barrier between you and the environment. Okay, and of course comfort. So when you wear a respirator, you make sure it's comfortable. If it's not comfortable, just for a few minutes, you will not be comfortable during your work hours, because you are wearing it for over 8 hours or so, right? So you have to be comfortable. You have to select a respirator that suits you and is comfortable for you. Okay, and of course training. Most important, a lot of respirator users, they don't put it on correctly. That's why it also resulted in the leakage in the seal. Like a full face respirator, a full face. Okay, if you sometimes a lot of people like over tighten the strap, right? But over tighten the strap also cause leakage between this. Okay, so and of course sometimes we have hair, then we wear a respirator, and this also cause a leakage around the face seal here because of the hair. Okay. So you must know how to really withdraw the respirator. And in OSHA standard, there's 2 methods. Okay, OSHA talk about qualitative and OSHA also talk about quantitative. And qualitative is very traditional method that is more towards what you call it subjective, because it depends on the personal taste to a certain solution. Like we use the nebulizer. The nebulizer contains either saccharin or bitrax. Saccharin is a very sweet solution, and bitrax is a very bitter solution. So we'll ask the person to don the respirator to do this test. Did you taste the solution? Okay, so these are very subjective. Sometimes you may take medication, you might say, oh, I don't taste the solution at all and stuff like that. Okay, and most of the people might not even know they have taste sensitivity towards certain solution. Like they can't taste saccharin, they cannot taste bitrax, so they might not have options at all. Right? Okay. And this is definitely what I'm introducing here, the quantitative method. It's definitely more objective. We did ask you to taste a solution. We put it, we basically use the equipment to quantify the data in real time as well, to quantify, because this equipment counts particle. So we are challenging when they put on the respirator, this instrument challenge the ambient particle versus how many particles that leaks through the respirator. So when you go on the respirator, they will check how many particles in the environment. Probably there's 4,000 particles here. How many goes inside the respirator in between the face seal? Okay, so this is very accurate compared, of course, to this small individual taste time. Right? Okay. Okay. So now let me show you. So we'll take some time to warm up. I need a model to put on the respirator so I can show you in real time. Model. Okay, I can. Not to worry if you can't see what's displayed on the screen here. I'll project it on over here. This machine can be controlled using this software, which we call it Pro software. Okay, or you can manipulate the screen using this touch screen in this equipment here. Either way, touch screen here, or you can use software to control this. Okay, and there's no internal memory here, so everything will be saved under here. Or if you have to use this to control. If you are using the equipment to control, then you have to use a flash drive, thumb drive, so that the data will save into the thumb drive. The fit test data, okay, will save into the thumb drive. Okay, and let me show you. So now it's I need to hook it up. one there's a cross rate, it changes to grade. So it's communicating with my PC. Okay? So I need a model, please. This is a N95 respirator, okay? And I already put the mask, okay? So for pollen count, okay, fit testing is conducted in negative pressure mode. Okay, for example, you might be donning a full face respirator for firefighters. They have the cylinder tank, right, with a positive pressure. But when you come in for fit testing, it's done in negative pressure. You have to remove the cylinder tank, everything that's covered in negative pressure. Okay, so don't worry, for full face respirator, we have adapter kit to convert to negative pressure mode. For this, so once the mask, like this disposable mask is broke, normally you don't use it anymore, right? Or it's intended for fit testing. Then you put, we have two tubing. Just now I mentioned we are challenging with the ambient aerosol. So the transparent tube is trying to measure how many particles leak through the face seal, right? Then the blue one is to measure the ambient. We are doing a comparison between both. Okay, we go to real time. This is very useful. This real time mode is very useful. I'll show you how useful it is. But I'm so sorry because the screen itself is not. I can't. So you look at this, because this machine can connect 4 pollen count at the same time. Okay, the screen, the resolution is not very good, but okay. Okay, so now you are seeing that the ambient there's 270, around 280 plus particles in the environment. So sorry. Okay. Never mind, assuming it's new, you don't know how to don his respirator. That is the way we want to show you. Okay, just now you can see, okay, we have to challenge the ambient aerosol. Okay, so it's around 270 over in the environment. And for the mask, now it's 134. So out of these 270, 100 over particles actually leaks in through the mask. So is he wearing it correctly? Does this mask suit him at all? I think it feels very badly. Yes, can you? Okay, let's take a look at this number. The fit factor is only that low. We want the fit factor to actually go 100. Okay, see, he can achieve this with 100%. Okay, smoothen down the nose strip. Just take note, any changes can he make to the respirator? In real time, this will show. You see, this will go down, and this fit factor will go down. So this machine is telling you very real time how to wear a respirator. Are you wearing it? You see? So just now he started like that. So this type of equipment also can tell your new workers who came on board how to wear a respirator. And does this respirator suit him? For OSHA, for a disposable filtering paste piece, you need 100 to pass. 100. For full face, you need 500. Of course, full face gives us more protection. You need minimum 500. Okay? So you see in real time how much is wearing? Of course, this definitely don't suit me. It's too big for me. I know they have different sizes, but frankly, I like this kind. The folded one. I'm not trying to sell respirator here. So we have the folded one, but this normally works very well. It works very well. And we have a few mask manufacturers like 3M. Right. They also own one of these instruments. Although 3M they sell the nebulizer, they sell the saturated bittrex kind of nebulizer, the taste sensitivity. But they also own this equipment because they also have to demonstrate to their customer if this respirator is better than their respirator. So they actually own this equipment to sell more respirator to their customer. Yeah, that's how 3M works. they are not keen on selling the nebulizer, they are keen on selling more respirator. Okay, so yeah, you see the more and of course this is the real time work. You can teach people how to go the respirator. Does it fit you? If it doesn't fit you, then you have to change to another respirator. No point going to do the OSHA exercise. Because OSHA has 7 exercises, including brainwaves will be 8 exercises that you perform in your workplace motion. Like because you wear respirator, we do certain work like we drop the pen, we pick it up, or we turn it side to side. So OSHA have all these exercises, and every exercise is 1 minute. Okay. Yes, I can show you. We have the equipment to do that. Yeah, I can show you later. So basically, sometimes when I wear this respirator, it is fine with me. But when I start to do the OSHA exercise, the fit test exercise, like up and down, turn it side to side, I feel it because I stretch my neck muscle. Sometimes I feel the test. So there's 8 exercises for OSHA, so it determines if this respirator suits you, you have to do those exercises. Okay? So those exercises is very valid because when you don't have a respirator, you don't expect to be sitting down doing your work, right? You don't have a respirator, you have to do your work manually, turning around, So you must tend to stretch your neck muscle and your respirator might expose. Right? So that's how we actually quantify if the respirator suits an individual. Okay? Okay, I think I can show you the test. But this screen is not the resolution, I'm not close it. Computer expert. I need to close this screen. The screen resolution is not quite. Okay, that's why, because below of this screen there's a close switch off button, even start button, but it's not visible here. Okay, I can show you, and of course, I don't think I will spend time showing you the software, but the software is very useful because it stores this data. So once every individual done a fit test, they pass, they have the minimum, I said 100 pass factor for this. So if they pass, they will be issued with the same size for the style of respirator. Okay? So and the data will be automatically saved in the records. Okay? So they can have a fit test card also. Say they pass this respirator model and stuff like that. Okay? So all the records will be saved here, not like qualitative, normally you have to use a paper and pen to jot the data and stuff like that. But everything will be saved here. So it's very useful, and even from the data, you can create a lot of reports. You can create report like who is due for fit test soon, They can create in 6 months time and stuff like that. They will generate the data out. So for example, you have your company have 100 people doing fit tests. So your data will come out like that. Who is due for fit test in 3 months soon? Okay, around that. So these are the 3 persons due for fit test. Or who filled the fit test. So they also can pull out the data. Okay, you just filter accordingly who filled the fit test, then they will pull out the list who filled the fit test, and they might have to conduct the fit test. So these are very, very useful information. To start a fit test, this is what I was saying just now. Okay, as I mentioned that it's based on OSHA standard 134 respiratory protection program. These are the 8 exercises that you have to do. Okay, so but not to worry because OSHA only recommend you to pass the overall exercise. So even if you fail 1 or 2, you must look at overall exercise. Okay, so OSHA talks about workplace motion that you have to do all these exercises. So certain exercise that I mentioned that you do inside to side, you tend to stretch your neck muscle. Sometimes the respirator will fail. Okay, it will fail. Okay, so this really mimic workplace motion. Okay. So just now somebody was asking how do I probe this respirator. Comes with this model. So we are using this equipment here. So go through here. Remember that we are sampling the breathing zone, which is between the nose and the mouth breathing zone. Okay, so we have to position around somewhere slightly below here. So we have to put this in, and on the other side, we put this to push up together. Yeah, then we are able to sample on the side. Okay, for those full face respirator, that one normally we use an adapter. Because full face adapter you can't have a probe. Okay, so normally you have to use the adapter. Then convert the adapter and cartridge. And minimum P100 cartridge. Okay, so we're able to convert to that.
If you use the two categories, means there are two adapters.
Yeah, okay. So this side will have adapter. This adapter will have the tubing. So this tubing will go through one of the adapters. You have to go through inside. There will be a small little tube going through the breathing zone here, right, for full face respirator. So this side will have to use a P100 filter to block the So after when you use the adapter, you have to put 2 P100 filter. Okay, minimum P100 filter. Because you're using 95 or whatever, 5% will go in, right? So it doesn't, the data will not get. Okay? So minimum P100. So, any more questions for these optics that you would like me to show you? So, this one, basically a lot of mask manufacturer own this. Also, not only for industrial player, mask manufacturer own this because we also want to tell those respirators, which is good for majority of people. Even hospital, industry, mining, and as long as they wear respirator. As long, this one can be test as long as tight fitting respirator. Loose fitting hood, no. Tight fitting respirator you can. Because respirator fit testing is to test the face seal. So if it's loose, hood, no. Okay? As long as it's tight fitting respirator, won't fight. Okay? And all respirator, be it N95, efficiency 99% above also can. Okay, that's that. 99% and 95. I think okay. You want to do the dust track. That's all for polycount, which we'll talk about the respirator fit testing. That's how it's being used in the market. Unless you want me to show you the data, which I don't think we want to spend time on that. Because the data also can create a new list of the people coming for fit test, they create a chart of data list, and you can even copy next year the 6 people coming for fit test, you can copy the data. So it's very useful. You have to generate your own data. Okay? So let's do the last track.
easier to enter the world.
So the dust track is, I brought along a dust track DRX, the multiple channels, right? The inlet is here, okay? I like to show you the gravimetric sampling cassette. It's right here. Downstream of the optic chamber, you can remove it. Of course, you can put your own filter media. Okay, so you can just remove it. Okay. Now, what is the sheet airflow? This one. Sheet airflow. So I was saying, this is the gravimetric sampling cassette. You can remove it, and of course, you can put your own filter media. Paper, of course, you will see some of the bigger particles like here and there going up through. Okay? So it's a really indicative instrument that you can see. And after that, you also can go to, you have a lot of the data, you can look at the graph trending as well. So of course, you can have a different display, like I will display the IAQ, then you have a full display, PM1, 4, 5, 10. Then you can display IH, okay. So it's indicative. Okay. And you also can program it. You can program lock it. For example, I want to collect data. I want the instrument to run at this specific time. Okay. And only 1 hour later, the instrument will stop running. You can program it as well. Okay. So there's program mode, different mode for this. Manual mode, program mode. Program mode can set it. How you log the data, you want it for how long and stuff like that, when you want it to start. Okay. So I can repeat how you want it to start. I think that's pretty simple. So like I mentioned, yeah, at the same time it's showing all the files. Total is 50 micrometers.
Yeah.
This is our more on the desktop version. Of course, we have the handheld portable one that you use to move it around. The very very survey and stuff. Now, of course, yeah, it's not I mentioned about the environmental one, it's outdoor. they don't really fix it at the outdoor, but they just move around. They still move around. It's still live. The battery power is still moving. That's how you want. Any other preference? You know, you can come over here and take a look. Yeah. And of course, we also have software, comprehensive software where you can analyze the data trending. You can pull up 2.5, pull up PM10 particles and analyze the data different time of the day and stuff like that. Yeah. That's our using our Track Pro software.
Do you use the same central media with the things that answer as before? Yeah, you have to extend something like that. Same media?
I don't supply the media filter media. You have to get it from third party. Yeah. I only supply the cassette. The cassette, gravimetric cassette is a 37mm filter cassette. The media, you have to get it from a third party. Yeah. Because we don't do that and we don't weigh that. Yeah. Okay? Just that we give customer the option, you still have that options where you can analyze the composition of the particles and stuff like that. And of course, you can also set alarm as well. So if you reach certain threshold, the alarm will sound. Yeah, you also have that feature. So real-time photometer has this sort of feature where it's an indicating device. Yeah, you reach certain threshold, it will sound, and the alarm will sound. I think it's about it. Any more questions?
Bagi yang mau bertanya atau mau lihat langsung, boleh langsung ke depan aja. Mau lihat program-programnya, displaynya, silakan lihat aja. Yuk, untuk para peserta yang ingin melihat langsung atau bertanya langsung kepada
muncul di sini.
Langsung ke alatnya, bisa nggak?
Bisa nggak mau munculin di sini atau
Ya,
cuma direkam
di situ? Tapi di ini juga ke alatnya. Dilihatin ke alatnya. Kelihatan nggak sih?
Ini di situ nggak muncul tuh. Kalau gini, hah? Ini gimana, Fe? Bisa situ? Bisa situ gimana?
Oh, lagi dipakai nggak bisa?
Wah, enggak juga. Tadi dia minta biar muncul di situ. Terus gue suruh mainin.
Same concept. Yes. That's the same concept. You will not, because full-face elastomeric, they will have to probe, once you probe the respirator cannot use. So they will have the adapter key.
Faye, do you want it? Dia mau pakai. Kayak mau pakai lagi tuh.
So I mentioned that the full-face respirator, the pass factor is around 5%. Also it depends on your government.
Trofinya gitu.
Firefighters in minimum 1,000.
Tadi di sini, kalau kemana?
Di situ atau gitu?
Because like CBRN, you're the front line, they go really much higher factor. Right? You need them more. Higher it is, you're more we talk about the because Nayok is the one who certified the respirator. This is full face like because full face definitely more protection. Somebody wants to look at how the cartridge looks like. I can show you. I'm not sure if this picture is very clear. I don't think this picture is very clear, but I don't have a clear picture to show you. So, like, half-face elastomeric, I was mentioning to the participants that you have to take a sample from the breathing zone, so you will need the cartridge and the adapter kit. So basically, either one side, right, either one of the filter side, you remove the existing filter, you put in the sampling tube inside, you measure the breathing zone. Then after that you have to cover it with the P100 filter on both sides. I'm not sure if they have the adapter. Sample like SCBA like this, yeah, something like that. Don't worry, we have developed a lot of different adapter kit for different brand, Scott, 3M, different mask manufacturer. We do have. But most important, you have to let us know what brand of respirator you're using. Right? Is it a threaded connection? It could be a BioNet. 3M normally is used BioNet or filter. So from there, we make sure the connection is correct. Yeah. Okay. Because when you plug, when you remove the filter, there's this, so you put the TV inside the adapter, make sure the connection is correct, put or screw in, and so it develops. It will, especially for respirators, these are developed specially for respirators. So if PSI don't have the specific adapter kit, sometimes the manufacturer, they must manufacture it because manufacturer they also do. We do have a wide use of why the mask manufacturer.
Oh ya. Boleh, kapan?
Any other questions? If not, soon I'll be giving out the prizes. Thank you. So if you have no more questions, probably I can present the prizes now. Okay, sure.
Sorry, I'll just take 1 minute to answer one of the question on the backfilling just now. I promise that I will show you some slides on it, just one slide.
Jawab pertanyaannya.
Okay, so very shortly, I mentioned about backfilling just now. There's a positive way and there's a negative way. This is a positive way. I mentioned about the air will go through the pump and then after that to the back. This is the negative way, which we can minimize contamination. Same bag is here, the outlet is here. So we close this enclosure, same pump but it's drawing the vacuum. So when I draw the vacuum over here, this bag will be forced to inflate itself. Minimal contamination. So that is what I mean. So when we are doing backfilling, this is the accurate way of doing it. If you want to do this way, make sure that the pump is clean. So that's actually what I wanted to show. Huh?
Baik, sudah tidak ada pertanyaan lagi, tapi kami siap Bila ada pertanyaan lebih lanjut mengenai produk DSI dan SQC, mungkin bisa menghubungi Hasilan Capital. Selanjutnya adalah pengumuman surprise. Baik, langsung saja saya silakan kepada Miss Sofia Chu.
As I mentioned earlier, I have 3 prizes. Okay, let me read out the names. Okay, and, they actually have quite the same score. Okay, the prizes are all the same. It's an iPad mini. I don't own an iPad, so I'm not very sure. iPad mini 2, 32 gig. Okay, so yeah, the first. Okay, I will call out the names. Mulyadi. Okay, I think it should be him because he was seated there and so I believe he paid a lot of attention also. Correct.
Siapa namanya, Mas?
Okay, the next is Mufti Rahman. The last is Muhammad Jaja Kambudi.
Thank you. Thanks to all.
Baik, ternyata belum sampai di sini. Door prize-nya masih ada.
Ya. Ini door prize-nya pertanyaan langsung dari Principal SKC dari Dr. Kennedy. Akan memberikan pertanyaan, 2 pertanyaan bagi yang beruntung. Gitu ya. Pertanyaan tentang produk yang sudah dipresentasikan.
My questions probably are more related to the field already. Not, it's not, you can't find answers from my slides anyway. So the first question, if anyone know, raise your hand and explain to me why your answer is such and such, okay? My first question, does anyone know? Give me maybe 2 scenarios. Why do we prefer passive sampling for gas and vapor to active sampling? Or can you give me 2 scenarios whereby you will deploy passive sampling rather than active sampling? Anyone? Passive sampling, remember passive sampling is when we use or we sample without sampling pumps. One example, just one example will do. Anyone? Yes, passive sampling is without pump. Active sampling is with pump. Remember just now during the hands-on demo session that I showed you over here, I showed you that there are some methods that we use, some of the methods we are using passive sampling, correct? Give me one example, why do you think in certain situations we will prefer to deploy passive sampling? Just one example. Oh, okay, I have the hands up, okay. You can give your answer in Malay also, they will translate for me, or if you are comfortable with English, you can try.
Mungkin passive sampling lebih cocok digunakan untuk jenis pekerjaan yang dia riskan terhadap elektrik, misalkan di pertambangan.
Translator, please.
This answer is passive sampling is more suitable if there are issues with